So we are going to start lecture 2 and I will switch on the camera. So before going into a proper preparation for PDE, I want to give some loose talk on this. When you are learning PDE, what should be your target after finishing PDE? What do you want to achieve? So guys, in PDE we have some special types of PDEs like we discussed in previous lecture 1, like wave equation, heat equation. Those equations you should know how to solve if the boundary conditions are given. Okay, and I want to connect this here. This PDE, whatever you will see, you will learn here. There is a subject called CFD, Computational Fluid Dynamics. Many of you will take that subject as a coursework in your master degree, MTech, MS or PhD. There is huge chance if you are turning towards aerodynamics or propulsion, there is chance you may take that subject as a coursework. So there you have to deal with partial differential equations. So right now in these lectures, you will understand that boundary condition, initial value problems, and there you will be using them like in very good volume. Okay, so before going into structured way for the PD preparation, this was a loose talk that for GATE aerospace exam you are not going to solve lot of PDEs and all types of PDEs, only some special types of PDEs. How to solve them means mainly their solution. How to solve them means mainly their solution, how to approach the solution, that you have to learn. When PD lecture will get over, then you should be able to solve few things in that. One special thing is if heat equation is given, wave equation is given, you can identify the nature, you can identify the approach how to solve. That's all. This should be your approach, and some fundamentals what we saw in lecture 1 and whatever we'll see in today's lecture. So now what should be our plan for the PDE? So it is similar to ODE. We have different types of PDEs, so we have different types of approaches to solve every PDE, but we have to see only one approach to solve. That approach is known as separation of variables method. Okay, in separation of variables method, what we do, we learn when the topic will come. So this is the main important method what you have to learn in your syllabus for GATE aerospace exam. So first we will start with a simple PDE where you are going to solve PDE without using any special methods. You may have some names also. Okay, like Monk's theorem, you may have heard this variable separation method, means separation of variable method. But without all these things also, there can be approach which is very simple approach to solve PDE, but that approach is not valid for all types of equations because this is the beginning of the PDE. So in the beginning itself you should know how are we generating PDE, how are we developing PDE, how are we getting PDE. Okay, so in lecture 1 you saw that one equation is given, and with that equation you are converting that equation into PDE by what? By differentiating them. So just integrate the differential equation and you will be getting your solution. Again I'm repeating, if you have a normal equation, that normal equation you differentiate and get the PDE. Just opposite you do. Here in this chapter you have PDE and you integrate and you can reach to the solution. So this is the simplest method, but this method is not working for all types of complicated and special PDEs, right? Now here in GATE exam, whenever question comes from PDE, your first approach is you should always first approach try direct integration. Direct integration is helping or not. By seeing question itself, you'll understand that okay, by direct integration we can solve this or not. So first we will see that a simple PDE is given and we can apply direct integration method and we can find the solution. So in example I have taken dou cube z by dou x square dou y is equal to cos 2x plus 3y. Now in this example we can literally direct we can do integration direct and we can find the solution of this PDE. Now you see here, what is the meaning of this dou cube z by dou x square dou y? Okay, meaning is very simple. See, z will be function of x and y. Okay, so first you differentiated your z with respect to y, then you differentiated with respect to x, then you differentiated with respect to x. That's why first y came, and then x came, and then one more x came, so x square came. Okay, it means what? In this direction we started differentiation to achieve this PDE. First we differentiated for y, then x, and then x. Then reverse, you go for integration in this direction. First you integrate for x, then you integrate for x, then you integrate for y. Okay, now one more thing you should know. So I have shown here this dou q z, that dou cube z by dou x square dou y means what? Meaning is, just a moment, meaning is this dou cube z by dou x square y, meaning is here you have 2x, means x square is there, so x into x. So first dou by dou x, this was the last differentiation done, and then inside what is remaining? Dou 2z by dou x to y. Now this is giving you idea that okay, in this also dou x was done and dou y was done. So it's like first we differentiated for y, then whatever answer came, then we differentiated for x, then whatever answer came, then we differentiated for this. So this all together became your dou cube z by dou x square dou y. Okay, so we have to do integration in this order. First, like from backside, x, then y. So means function was given as z is equal to fxy. Then this differentiation was done first, then this differentiation, then this differentiation. Okay, which made you final dou cube z by dou x square dou y. Till here only fundamental is going on. Now let's go back to example and solve the example. So this is your example. Let's solve them. Now first we have to integrate from the last side, so it means we have to integrate for the x. So here meaning is, whenever you see something written like this, then the last part is this, means this you have to integrate first, then you integrate second, and this one you integrate in the last. Okay, means with respect to y, integration should be done in the last. After first integration with respect to x, here this is remaining, and first integration you did this one. Now after first integration with respect to x, y function of y should come in your answer. After first integration with respect to x, y function of y should appear in your answer. Very logical talk. See, imagine you have a solution, you have equation. In this equation function of y is present. When you will differentiate with respect to x, then function of y will become 0 after differentiation, correct? So this will become your partial differential equation. From a normal algebraic equation or whatever mathematical equation, algebraic, logarithmic, or trigonometric, or whatever exponential, if you differentiate with respect to y, then all the y terms will become 0, right? So that's why while integrating, I don't know which y term will come, so that's why I will write fy as unknown function. It is there, but I don't know what is that fy, because I'm going in reverse order. While integrating, fy should come. So that the fy I wrote. Now again I will do second time differentiation. When I will do second time differentiation, then only dou z by dou y will be remaining in the left side, and this trigonometry part, you know how to sorry, not differentiation, integration we are doing. By mistake I said differentiation, integration we are doing. So you integrate the first answer, we got this integration is easy, trigonometry integration, and whatever fy was there, that fy also I integrated for by using symbol dx. Okay, now when you integrate function y, this function y will change and it will become function phi y. Fy will become phi y. I can use any symbol, f, g, h, x, I mean any function, but only in the bracket I should write y, and I will say that this was function of y and it became new function phi y. And integration of dx, you should write one x also here, because when you integrate it will become your x. And then this extra gy you have to integrate, because this is your second time integration with respect to x. So in first time integration fy appeared and then gy appeared. All right, so here I am telling you why, on what basis I wrote fy as phi y, because when you integrate fy your function will change, right? Like sine will be cos, cos will be sine, something like that. So now last integration is remaining with respect to y. So that integration, if you do, you got z is equal to this much, then here you got this much, and then you got this much. Only symbols I have used. Final answers you can use another variable. When you integrate phi y for with respect to dy, then what will come, you know. When you will integrate phi y for y, phi 1 y will come, new function. When you integrate gy with respect to y, a new function phi 2 y will come. That's all. This became your solution. So this is the required answer. But here I will talk something. In this final answer, whatever two functions we have got, phi 1 y and phi 2 y, those two functions values we don't know. So to find out those values, to find out these two values, what is required? To find out these values, what is required? Initial value or boundary values. If these two values are required, then only we can find out these functions what is their original phi 1 y and phi 2 y. If values are not known, means initial values and boundary values are not known, then we cannot find out. Same thing we saw in ODE also, right? So if boundary condition or initial values are given, then fine, we can find out, and that final answer will be that one after finding out. Otherwise this itself will be final answer. This situation we saw in ODE also. So to know their values, we need initial values and boundary conditions, or both. Also you should know one thing, when you have to find out the constants, or when you have to find out the functions in the last, that time boundary value should be given, correct, or initial value should be given. So those kind of problems where everything is mentioned, they are known as boundary value problems. Okay, when you will learn CFD, then see guys, in different IITs some courses are there, like CFD is there in every IIT, but in some IIT some advanced courses are there, like advanced computational gas dynamics, like that is gas dynamics course, but there they are solving using the concept of CFD. Okay, and also in my knowledge, people who are having coding background in CFD, like CFD is about, not exactly about coding, CFD has its own way, discretization, blah blah things we study, because I have done CFD course. So this whatever you're learning here, this will be directly helping you in those courses. So not only this, you should learn PDE beyond GATE aerospace preparation, and I hope that in college or university level programs, whatever they teach, that you feel that what is going on. And if you don't feel, find time, some books are there, Krasik book is there, BS Grewal is there, HK Das is there, or I mean for subjective learning you can, or YouTube is there, lot of good teachers are there on YouTube. You can get some more detail, because anyway when you will be dealing with some courses where partial differential equation comes, boundary layer problems will be coming, that time you will be feeling that okay, I'm lagging in PDE. Okay, so that's why you have to go into more detail if you are bothering for those kind of courses. But this video session, whatever I am teaching, it is just for GATE aerospace. Okay, so whatever good and crisp thing for GATE aerospace, only that much I am putting here. Okay. So we will see one example. In this example, again another example I have taken, again dou 2 z by dou x dou y x square into y. This problem again we can solve directly by integration, but this time conditions are given. You can see given conditions: z x0 is equal to x square, z1 y is equal to cos y, right? So this given condition means, you can see, I will tell you what is the meaning of zx0 and is equal to x square. It means what? See, if it is written z, then it is written some 2, then it is written suppose some 3, and that it is written suppose some 4. What is the meaning? Meaning is, for x is equal to 2 and for y is equal to 3, whatever equation was there for the z, that answer came as 4. For example, if I write z is equal to, suppose I'm writing x minus y, then I know that this is the solution of any particular PDE. Currently it is not solution for my PDE, but I know that okay, this is the solution for any particular PDE. So now in this solution, if you put x is equal to 1 and y is equal to 1, your z will become 0. So that kind of thing it is given here. So now understand my given condition. My given condition, why are we giving? Why condition is given? So that any constant or any unknown function we should not leave in our final solution. We should use these boundary conditions and we should find out their exact answers, right? So this z bracket x means for any value of x but only y is equal to 0. Z comma 0 means, sorry, x comma 0 means, what is written? Z x comma 0 is written, na? Is equal to x square is written. What is the meaning? For any value of x, that's why only x is written. X is equal to x. You can choose any value, 1, 2, 3, 4, whatever value you want. But y is equal to 0. Y has a limitation, only one value. Which one? 0. Your z will come x square. This is the meaning of, and same thing here. For any value of x, sorry, for any value of y, but x should be only 1 because it is written z comma, sorry, z bracket 1 comma y. So answer will come cos y. Which answer? Z will come as cos y. Now go for solution of this. So you know what is the meaning. You have to integrate from this side. So first you integrate for x, then you integrate for y, because differentiation is done in this direction. First they differentiate for y, then differentiate for x. This is what I taught. Okay, so integrate with respect to x. So this term is easy to integrate. Automatically one y function will appear in the final answer. Then integrate for y. So this fy integrate for y, and then gx will come automatically, because when you integrate for y now, then x terms will start coming. When you integrate for, listen what I'm saying, when you integrate for x, then y functions will come. When you integrate for y, then x functions will come. So finally we got two unknown functions, fy and gx. This here itself we can stop the problem if those conditions are not given, but those conditions are given. So in GATE exam you have to use those equations and you have to find the answer. Here I have explained that this is your x value, this is your y value, and this is your final z value for these values of x and y. So now using these conditions, means these conditions, we have to find out. So two conditions are given. So for every condition, one function you can find out. So let's apply first equation. For x equal to 0, for y is equal to 0, z is equal to x square. Correct? So when you use this pattern, z is equal to x square, you can see x is equal to x, y is equal to 0. So I'm putting like this. So I could not find phi, but I got gx value. You can see here, from here I got gx value, but the gx value contains phi 0. Don't worry about phi 0, just follow the procedure. Phi 0 will get cancelled automatically. So gx is equal to x square minus phi 0 is your. Now put back this equation into main equation. So into main equation where you had gx, that gx I replaced with x square minus phi 0. Now use second boundary condition. Second condition says at x is equal to 1, y is equal to y, z value is cos y, right? So substitute this equation. So substitute x is equal to 1, y is equal to y. So you got this equation. From this equation from this equation you got another phi y. So this phi y also you put back into the main solution. So from here to here it is phi y, and whatever is remaining, I mean overall, after substituting overall, you can see this overall from here cos y minus y square by 6 minus 1 plus phi 0. When you will substitute in this z equation everything, that time this x square is extra, that this x square is coming because of the gx, right? So that phi 0 got cancelled. Okay, so now go for lecture 3. So this became our here final answer. Here we learnt how to apply boundary condition. Understood? Go for next. I will stop the recording.